What I'm going to brief in this lecture is slabs. So slab comes under which unit? Unit number three. First
Three,
unit is
sir.
all about, yeah, thank you. First unit is all about working stress. Second unit is all about limit state method, beams and shear design, torsion and all. So third unit is slab and staircase. Staircase is also a slab only. So if you know how to design a single slab, right? So you'll be able to design beam as well as the staircase. Both design procedures are same. Slab, stair, and beam both are all three elements are under flexure only. So it is the procedure is very quite common. Only few things you have to add or you have to delete it. That's the only difference as far as design of slab, beam, and staircase is concerned. Moving on with very basic of slab. You know what is a slab? What purpose it serves? How the load is being distributed. Based on the spanning, the slab is classified into two types. One is one-way slab and another one is two-way slab. So if your Ly by Lx, what is Ly? Length along y-axis and Lx is length along x-axis. When I say x and y, you can usually come to conclusion that if I say a slab size of 3 by 5, so the 3 is x-axis and 5 is y-axis. 3 meter by 5 meter. 3 meter cross 5 meter. So 3 meter comes under x direction. 5 meter comes under y direction. Always please remember the ratio is Ly by Lx, not Lx by Ly. The y-axis is the dominant. It has to be in the numerator. So Ly by Lx. If that ratio is greater than 2, then it is a one-way slab. If it is less than 2, then it is a two-way slab. If it is equal to 2 also, it is a two-way slab. This is a very basic classification of slab based on the span. When I say span, it represents the length of the slab in both direction, x and y. It's very clear. So this is one type of slab classification. The other types and all you can um, come up with the material RC slab, steel slab, or you can come up with supports. So if it is simply supported or not, then simply supported slab. If it is a cantilever support, then it is cantilever slab. And the support is very continuous or more than two supports, then we'll call it as a continuous slab. For all these three, that is cantilever, continuous, and simply supported, the only span by depth ratio, which is given in the code IS 456, that alone will get changed, remaining and all same. Once that gets changed, what will happen? The moment also will get changed. You know what is the moment for simply supported beam with UDL? What is it? W L square by 8. When it comes for cantilever, then it is W L square by 2. So this is what you have done it in strength of materials. That's why I keep on saying why strength of materials is a base for the other subjects and all. So it's very clear, very simple as well. So what type of a support the slab is given and what is the spanning ratio Ly by Lx greater than 2 or less than 2 or it's equal to 2. This is what first you have to understand in slab design. So once you're clear with that, this you can identify from the question itself. So once you're clear with that, you can proceed further. Here you can see the direction, what it is given. See here from this A diagram, you can easily understand which is higher is Ly and this is largest, shorter span is Lx, longer span is Ly. So based on these two ratios, Ly by Lx, we can calculate whether slab is one way or two way. And this is what I said, basic rule for design. Here you can see the basic rule for design is effective span. So control of deflection, what you have to do, span by depth ratio. Span by depth. Here the depth is effective depth. So span by depth ratio 7, then it is a cantilever slab. Span by depth ratio is 20, then it is simply supported or continuous if the span by depth is 26. Right. So this you know very well. Yeah, we have discussed enough already. The one thing you have to keep it in mind here is very important thing is this one. This is a separate topic where you have to use it in your design part. This is very, very important. Nothing to worry about these points. All these points are available in IS 456. Here you can see, is my code book visible? I'm changing screens. Is it visible?
Yes, sir.
Yes, sir.
Yeah. So here you can see in the page number 46 of IS 456, they are given requirements for reinforcement for a structural members. So here, first member is they have given is beam. So what we want for slab. So if you go down, you can see here it is given that is 26.5.2 slabs, right? So here they have given the necessary conditions for reinforcement. That is what given here. What is the minimum requirement? What is the minimum reinforcement has to be given? What is the maximum diameter for the slab has to be given? What is the minimum diameter for the slab has to be given? Right here we have two bars. One is main bar, another one is a distribution bar. Here you can see the slab directions, behavior of one way slab. I'll show you what is the bar, what is main bar and what is distribution bars. Is my slide so visible? Again, a diagram, reinforcement diagram for one way slab.
Yes, sir.
Yes. So here you can see the first thing here it is running as a bent up bar. This is your main bar in this direction. What is this direction? LX or LY? LX. So LX direction, you have a main bar. Perpendicular to that direction, we have a distribution bar. This has to be very clear. LX and LY. Only these two you have to understand. Main bar is here on the, I am talking about only one way slab. So it is in the direction of LX. Distribution bar will be in the direction of LY. So this is the requirement they have given here. So what is the minimum requirement? Main bar, what is the minimum diameter and what is the diameter for distribution bars? This is what it is given here. You can directly refer the code book page number 48. It is given very clearly what you have to do. Minimum reinforcement, maximum diabar, minimum diabar, all those parameters is given here. You may get a separate question from slab, like what is the minimum diameter you have to give, maximum diameter, what is the spacing, all those stuffs, which is there in the code book 26.5.2 is there. These 3 points you can add up. See here, the rule given in 26.5.2.1, they are directing somewhere else. You have to go and you have to take that class. Please be clear here. If you see 26.5.2, it is given a slab. What it says, the rules given in 26.5.2.1 and 26.5.2 shall apply for slab in addition to those given in appropriate classes. So these two, in addition to what you have done it in the beam, that will be added. That's what it is. You please understand, don't get confused. Okay. And I don't want to get into deep, so I'll be quickly moving on with the problems directly. Please understand, very, very simple problem. We have only 7 to 8 steps. All the steps you know already. All the steps you know already. I'll give a two problem, which is I'll show two problems here. You can understand the problems first, then we'll move on to the procedure or the problem. What they are given? A simply supported one-way slab. They are given the clear span as 3 meter. Is supported. Is supported means simply supported. They have given already a simply supported. They also clearly specified it is a one-way slab and it is supported on a masonry wall of thickness 350 mm. They have given the wall thickness also. Design the slab. They are given the material what you have to take M20 and Fe415 grade of steel, and they are given the live load also. This is one type of problem. Question is clear. What they are given? Support condition is given, simply supported. What type of slab is given? One way or two way? What is the span length? They are given 3 meters. The thickness of the wall they have given 350. Grade of concrete given. Grade of steel is also given. The live load is also given. So necessary requirements, everything is given. I'll show another problem. Yeah, you can see here. Another type, same problem. You can easily differentiate what is given, what is not given, what you have to assume and all, right? Design a one-way slab with a clear span of 5 meter. Again, simply supported on a wall of 230 mm thickness, subjected to a live load and a surface finish of 1 kilonewton per. It has to be meter square, not mm square. So meter square. Assume Fe415 and assume the slab is subjected to moderate condition. So when you see, when you compare these two, you can see the second problem has new data, which is floor finish. And there are some absence of data when compared to the first question. What is the absence of data? The grade of concrete is not given. And what else? What else is not given? Grade of concrete is not given. Is there anything that has been left out? No, nothing. So what I'm coming to say here is just you understand only these are the datas we need for solving the problem. Only these datas. What you have to do is if something is not given, you are supposed to assume those particular data. For that assumption, you must keep those assumption in your mind. That is what here you have to understand very clear. Right? Only the question one, what I'm showing here contains all the datas. Right? Contains all the datas. If at all, if I get a question like this, the problem number, this one. Here there are some datas missing. Grade of concrete is not given, right? And if you go here, they're given only the live load, floor finish is not given. I'll tell you why I'm saying this. You're supposed to ask only one question, very basic question. The span, that's all. That's the only question you have to ask when you are going for a design. All other things you can assume based on your basic knowledge on design of reinforced concrete design, right? What I'm saying is which data you have to get is here is the span. That's all. The span condition, right? Let me ask you like this: if I get a span, what will be your first step? I'm giving a span. It is 3 or 4. I'm giving a number. What is the next question you have to ask? You are supposed to ask for another span. Then only you can get whether the slab is one way or two way. Very clear, right? The span condition, if it is given, see, as far as this question is concerned, span direction, only one direction is given, 3 meters. But they have given it as a one-way slab. So no need for the another dimension, that is Ly. I can assume it as a per meter length. So no need for another span direction. So first thing I need to know is one side of span. So span dimension is given 4 meter, 5 meter, 3 meter, whatever. So your first assumption, if nothing is there in the sum, you have to assume the next assumption is one-way slab. Right. What else? Next you will ask where the slab is resting. That's the next question. Correct. Span is given. First question is one way or two way. You can find that in the question. If not, you can assume. Next question, where it is going to support. Based on the support, you can understand whether it is a cantilever or a simply supported or a continuous. It is the support that gives you the idea whether it is been continuous or simply supported or cantilever. Again, take the same example, this problem. They are given, it is on the masonry wall 350 mm. Masonry wall means brick wall. Is it possible to embed the reinforcement or the concrete into the brick. Is it possible? Not. Definitely not. Is it possible to embed the brick into the concrete? That is also not possible. That is no use of doing that, right? So what that, oh, then what this represents? It is just resting on the wall. That's the point. I have a brick wall. The slab is coming and resting on the wall. So what does it mean? It is simply supported, right? Very simple, right? It is simply supported. See here, both the question they are given very clear. It is simply supported. So no need to worry about it. So again, you will ask for support and they are given it as a simply support. Then the next question, what you have to ask, the major question is load. What are the loads acting on it? Right? Obviously, we know dead load will act, live load, and floor finish. Luckily, for this problem, they are given the live load 2 kilonewton per meter square. And for this problem also, they are given it as 4 kilonewton per meter square. But what you have to understand is if the slab is constructed for residential building, then you have to take so and so load. If it is constructed for commercial building, so and so. If the thickness of the slab is so and so, then this will be the load. All those data are given in IS 875 part 2. Right? But for exam point of view, it is not allowed. Which is not allowed? IS 875 part 2 is not allowed for the examination. So then you ask, then how can I take or how can I assume the live load? There is a standard or a thumb rule for a residential building. You can assume from 3 to 5. It is given in the code book. Just for our remembrance, I'm saying it as a thumb rule, but it is given in the code book. So it will be from 3 kilonewton to 5 kilonewton. You can assume any values, if at all not given. That's very clear. If it is not given, you can assume from 3, 4, 5, anything. 3, 3, 3.5, 4, 4.55, anything from 3 to 5 kilonewton per meter square. This is live load. Then floor finish. Most of the cases, floor finish they will not give. Right? They will not give you the floor finish. So you can assume directly it has 1 kilonewton per meter square. You can add up to the live load. If live load is 3, you can add 1. If the live load is 4, you can add 1. So whatever the live load, you can take the floor finish as a thumb rule, which is equal to 1 kilonewton per meter square. So clear, right? So the span is given, support condition is given. We have found it, and the loading is also given. If not, you know how to assume it. What else you are supposed to do? The grade of concrete or the grade of materials, steel grade and the concrete grade. Definitely they will give. If not, the standard is M20 and FE415 for the exam point of view. M20 and FE415 grade of steel. That's it. These are the given data. It's very clear. So my point is first you understand the given data, then it is quite easy to proceed further. Do you have any further doubt on this? Just I have given only the procedure how to take or how to pick the problem, whether it is one way or two way or staircase, whatever. This is the procedure. If at all not given, these are the things you have to assume. இதுல ஏதாவது சந்தேகங்கள் இருக்கா? Do you have any doubts on how to approach the problem?
No, sir.
Fine, good to go, right? So I'm not yet started the design. Just I've given only the glimpse on how to approach the problem. This is design of slab, which is coming under unit 3. Okay, fine. I'll take the example of this one. Again, I'll show this also. I'll compare it and I'll teach you. Then it will be easy for you to understand. Right. Step 1. Very first step is, as you all know, what you have to do, you have to check the slab is one way or two way. See, design a one-way slab. They are given, it is very clear. It is a one-way slab. Just you have to check whether it is one way or two way. That's all. What is the procedure? Ly by Lx. What is Ly? One span is given, other span is not given. What you are supposed to take? நான் என்ன சொன்னேன்னா, ஒரு ஸ்பான் கொடுத்துட்டாங்க, other span கொடுக்கல அப்படின்னா you can take it as 1. So now the slab dimension is 1 by 5 meter. 1 meter by 5 meter. Which is Lx, which is Ly. 1 is Lx, 5 is Ly. So the spanning formula Ly by Lx. So 5 by 1, which is equal to 1, which is greater than 2, then it has to be designed as a one-way slab. Very clear. If it is 2 by 3 or 3 by 4, 5 by 6, whatever the number you put, you come to a conclusion with the spanning of Ly by Lx greater than 2 or less than 2 or equal to 2. Based on that, you just first identify the slab is one way or two way. Very clear. Okay. Then what is the next step? Depth calculation. Again, this also I have told you already. Once the spanning classification is done, then the other type of classification is support classification. Correct? So support classification, cantilever, simply supported or continuous. How do you find this? So already given in the code, span by depth ratio. I don't know where it is. Anybody remember the page number quickly? Yeah, I took it. 37. You can see here in the page number 37. It is cantilever 7, simply supported 20, and continuous is 26. Very clear. This sum, they have given it as a simply supported. So L by D, it has to be 20, right? Only one thing you have to add up here is a modification factor. Modification factor of 0.95. I'll give an example. Why this modification factor is taken? Only for the deflection control. Deflection control. For deflection control, you have to take a modification factor from this. So you can assume for initial stage, you can take from 0.9 to 0.9, 0.95 or 0.98. To that extent, you can take, or you can blindly go with 0.95. What happens if I have not considered the modification factor? No problem. If you are going with span by depth ratio, no sir, modification factor I have forgot. No issues, nothing wrong in that. You can go with the span by depth ratio directly, because this particular step, again, it will come in the deflection check. Once the problem is completed, you will be checking the deflection at the last. The design that you have done is okay, is safe against deflection or not, you will be checking at the last. At that time also you can add the modification factor, include the modification factor, and you can redesign the depth and all. No issues. Okay. So if you are doing it here, well and good, no issues. If at all you forgot or you missed it, no problem. Go with span by depth ratio. Span is 5 meter, depth is 20. You will get the D. Please be clear that D that you are getting here is effective depth, small d. You can see here in the code book, it is very well stated. Please understand the terms effective depth. You can see here the depth, it is the effective depth, not the overall depth. Fine. So I'm getting 270 as my effective depth. What you have to do? The overall depth. What is this 20? You have to add 20. What is that? Clear cover. Then what is 10 by 2? The dia bar that I am assuming is 10. So that center to center distance I have to take. So I'm taking it as 10 by 2. You know all these things. I'm just recalling. Be with me. It is very easy. Just to recall. You can refer your own notes. What we have discussed in classes. You can have that and you can solve the problem pretty easily. Done. Type of slab you have determined. Effective depth you have determined. And that is overall depth you have determined. Then the step 3 is effective span. Right? Once effective depth is done, then the very next step is effective span. Okay. So what is clear span? What is given in the question is a clear span. So clear span is 5 meter plus the effective depth that you have calculated in the previous step. You add it and keep aside the value 5.27. There is another thing, center to center distance between the supports. What is the support here? Brick wall is the support, right? Both ends it has been brick wall. So center to center. So 230 by 2 on one side, another 230 by 2 on the other side. That's why 2 times of 230 by 2. Or you can add up 115 plus the clear span plus 115. No issues. Right? You can see it in the diagram easily here. This is what I'm saying. Here, from this center, this is the wall thickness 230 mm. From here to here, this is my effective span. And this is my clear span. So effective span is nothing but the center to center distance between the support. So the wall is 230 mm, so it will be 115 plus that this inter-between distance is 5 meter, again 115, right? Clear. So you have two ways to calculate the effective span. I have two values, 5.27 and 5.23. So you will get a question, which one you have to choose? You have to choose the least value. That is 5.23. Why least? Why not higher? So higher the span, deflection will be higher. So least the span, deflection will be less. That's the reason. Primarily, we are choosing it for effective span as least of the two values. Clear? Type 1, step 1, one way or two way. Step 2, span by depth ratio, which is there in the code book. Just add up the clear cover and the dia bar. 10 mm you are going to use. You can take 10, 12 mm, then you can go with 12 mm. No problem. 8, 10, 12. Very worst case, 16. No need of 16 and all for the exam point of view. Go with 8, 10, 12. Again, 8 is also, you can leave it. You can assume 10 or 12. Okay, fine. Step 1, step 2, and step 3. Done. Fourth step is load calculation. Right? Everything is derived from the question only. That's why I said question, you just concentrate on the datas. From the data, you can easily understand the steps to design the problem. Right? Okay. First load is dead load. Here they are given live load, no problem. It is given in the questions, or they have taken and written the live load. Very first thing you have to do is the dead load calculation. Dead load is nothing but the self weight. That slab has some self weight. What is the slab is? What is slab is made up of? RCC, right? Correct. So RCC unit weight is 25. When I need to know the dead load, I have to do LVD. All the dimensions you have to multiply with the unit weight. You will get the dead load. So one direction is 1. Another direction they have taken it as 1. Instead of 5, they have taken it as 1. Why? Because I'm doing it for meter square. You might come across land sailing, right, in square feet. If you go and ask for any rate for the building, they'll say ஸ்கொயர் ஃபீட்டுக்கு 10,000 ரூபாய், இல்ல ஸ்கொயர் ஃபீட் 2,000 ரூபாய் அப்படின்னு தான் சொல்லுவாங்க. வெயிட் கன்ஸ்ட்ரக்ஷன் ஆர் தேர் செல்லிங். வாட் இஸ் தட் ஸ்கொயர் ஃபீட்டுக்கு 2,000 ரூபாய்? எத்தனை ஸ்கொயர் ஃபீட்? அது இல்லை, ஸ்கொயர் ஃபீட்டுக்கு 2,000 ரூபாய்னா ஒரு ஸ்கொயர் ஃபீட் 2,000 ரூபாய் அப்படின்னு அர்த்தம். ஒரு ஸ்கொயர் ஃபீட்னா என்ன? 1 into 1. So that's what here also you have to calculate. So 1 into 1, this is fine. L, B, and the depth I said, right? L, B, H. Here H is the depth. What is the depth? நீங்க தான் கண்டுபிடிச்சீங்க. What is the depth? It is 270. You can take 295. You're supposed to take 295. It is given as wrong because the overall depth you have to take, because even this 15 mm depth, and right, we have concrete, right? 25 mm depth also will have some concrete. So you can take it as 295 or 300. Round off to 300 mm. So it will be 1 into 1 into 0.3 into 25. Whatever you are getting, you can name it as the dead load. So you have dead load, you have live load, and as discussed earlier, you have floor finish. Add all these under the total load under working condition. So to convert the working condition into design condition, what you have to do? You have to multiply with the factor of safety. What is the factor of safety? Load factor of safety 1.5. So here they have done 11.75 into 1.5. You are getting the factored load. Again, I repeat, check one way or two way. Check for the effective depth. Check for calculate the effective span. Do the load calculation in 3 steps: dead load, live load, floor finish. Add this and do the factored load, or you can call it as a design load, whatever. 1.5 வச்சு multiply பண்ணுங்க, you'll get the design load. Step 5, moment calculation. Once you are arrived at the load, very next step is moment. You know very well, shear force diagram முடிச்சா அடுத்தது bending moment diagram. You have done it right. So once you are done with the force, then it will be the moment. So simply supported beam, it will be W L square by 8. You have the W, you have the span, effective span you have to take. So that is 5 point whatever, 5.2.3 divided by 8, I'll get the moment, right? So load is done, moment is done. Moment முடிஞ்சா next step you have to calculate the AST, right? Before going to this AST, you have to check whether the depth you have calculated here, whether that is correct or wrong, whether it is sufficient or not sufficient. You have to check it, right? You can see the formula here, M equal to QBD square. This Q is nothing but 0.138 FCK BD square. 0.138 FCK BD square. If I have a calculator, I'll show you. 1 minute. Yes. So 0.138 into BD square, 0.13 FCK BD square, right? Into 22.76. Give me a short break. I'm getting a call. Please hold on. Hello. Very sorry. Terribly sorry. I got an emergency call. Okay, we are with calculator, right? Yes. So 0.138. What you'll do, 0.138 FCK BD square is very common. That also from the code book. So here they have done it is nothing but 0.18 in 20. If you put, you will get 2.76. That is what they have given here. See here 2.76. QBD square is nothing but 0.138 FCK. FCK BD square வரும். BD square அப்படியே தான் இருக்கு. Q தான் வந்து 0.138 FCK. FCK என்றது grade of concrete M20. Okay. So here the only unknown is D square. If you take a root, you will get the value of D. You can cross check this value with what you have given. See here, it is 270. What I'm getting, it is 150. What is the difference? 120 mm difference, which is very, very higher. That's what I said. Even if you're not considering this modification factor, right? Let me do. They have given with modification factor, right? 500 by 5000 by 20. I'll do 5000 divided by 20. What I'm getting? 250. Even if you leave the modification factor, that will not affect. I'll get 250. It is coming it as 150. No problem, right? If you're going with modification factor, it is the right procedure. It is safe against the deflection. That's what. Okay, fine. So once you're done with the check, this check step is very, very important. Please don't leave it. Proceeding further, you cannot go, right? Then AST calculation, you know very well. We have done it, this formula more than 1000 times. Mu equal to 0.87 FAST formula, which is there in the code book. So you can solve it and you can do with the AST. Once AS is given, already assume the bar is 10 mm diameter, right? So from that, you can calculate the spacing. Spacing is small AST, the small A is nothing but 1 AST. 1 bar oda area, that is 78.5, divided by total area that has been given 300 into 1000, that will be your spacing. That's all. So provide 10 mm diameter at 260 mm center to center here. So this distance, you are providing the bars, right? This bar, this one. So 1 bar, 2, 3, 4, 5, 6, 7, 8 as goes on. Correct? So this distance is 260 mm. The bar is 10 mm diameter. That's all. Right? What is the next step you are supposed to do is you have to calculate the distribution bars. See, this direction you have given the bars. What about the other direction? Perpendicular direction you have to given, right? So that you have to calculate. Here also the same procedure they have followed. Here you can see. Fine. So next, moving on with the distribution bars. That's the code. Yes. So here they are given the provision for distribution bar. Yes. So the minimum reinforcement that has to be given, you can take it as the reinforcement for the distribution bars. That is 0.12 percentage. 0.12 percentage, or I'll show you another. Mm, I'll show you another example where you can go with the distribution bus. Yes, here you can see AST distribution. Here it is. Distribution steel, or you can call it as a secondary reinforcement, or you can call it as a temporary or temperature reinforcement, whatever you can call it as. Other names and all. But they are given the same diameter. So for the same area, right? What is the area provided? 581. What is the minimum area? 246. I have provided 581, but code says the minimum requirement, that is 0.12 percentage of gross area, right? That is coming as 246. For this 246, again you provide bar and find the spacing. End of the problem. That's all. Secondary reinforcement is very simple. That is distribution reinforcement is very simple. You provide the minimum, that is 0.12 percentage of gross area. 0.12 percentage with 1000, sorry, 100 into gross area 1 meter into 250, 205. As far as this problem is concerned, 205 is your depth of the slab. You can see here. They have calculated. Yes, the depth of the slab. What is it? Gross area, yeah, B into D. B is 1000, D is 205. So I'm getting 246. For this 246, you provide bar. See, there you have provided 10 mm dia bar to differentiate, and no need of that much amount of steel to be wasted. You can go with the lesser bar, that is 8 mm dia bar. So for the main bar, it is 10. The distribution bar or the secondary reinforcement bar, it is 8 mm. So 8 mm, again small AST by capital AST into 1000, you will get the spacing. That's all. Problem is done. Okay, clear. The last one is you have to do the reinforcement diagram. I have seen you doing the reinforcement diagram in your CAD lab manual. Anyway, do it correct. I don't want to comment on those things here. Anyway, you just understand the concept here. It is given very clear. See here, this bar that is along the perpendicular direction, 8 mm is the secondary bar. The main bar is given along the x-axis, that is 10 mm bar at 260 mm center to center. This is your reinforcement sketch. The same thing, if you cut it here, you will get to know which is main bar and which is reinforced bar. Sorry, distribution bar. That's all. One slab design is done. Why I'm concentrating on slab is like it is easiest procedure. The same procedure will be followed for beam also. The same process, the same procedure. Like, what the additional thing is, once you are done with the reinforcement diagram, right? After this, you will be doing shear check in the beam. For beam, you will do the shear check. no shear check for slab. You'll go with the deflection check. Instead of shear check, we'll go with the deflection check. If you do this much of till the reinforcement itself, it will take half an hour time. That is, I'm not exaggerating. Once you have done the problem, right? Once you are doing the problem, that too without seeing or without any assistance, definitely it will take half an hour time. So yeah, as far as exam point of view is concerned, till the reinforcement diagram is far enough. As far as 16 marks is concerned also, right? You have to write 5 16 marks, right? Right. So 5 16 mark na 3 hours la half an hour you uh, omit it for 2 marks. So you have only 2.5 hours. So one question carries time of 30 minutes. So one design, slab design, what we have seen now, it will take definitely 30 minutes for one problem. With that, you can stop with this. Now, if you have any queries, you can ask me.
No, sir. Kindly